there. In this section, we're going to finish off chapter 4.5 in Advantage Chemistry 12. And this time we're going to look at calculations involving KBs. So we're going to look at the second part of this chapter, looking at all of the calculations that would fall under like baseland. So two goals for this is we're given a Ka, we're going to calculate KB. And then we're going to solve problems involving KB. So things that are in calculating initial concentrations of weak bases, final concentrations, and looking at POHs of solutions, and then finally solving for KB. So the first thing that we're going to look at is how to derive KB. Because if we look at our chart, if we look at that Bronsted-Lowry acids and base, that comparison chart of how strong they are, you'll notice that it has the Kas but not Kbs. And this is done for a reason, because it's actually very easy to calculate a Kb if you know the Ka. So first off, we're going to derive Kb and where it comes from. You can see here that I have this equilibrium expression for a weak base. So when I take that weak base and place it with water, the weak base will act as a proton acceptor or a hydrogen ion acceptor. It will accept that hydrogen ion and become the conjugate acid, Hb+, and create that hydroxide ion that gives it its basic properties. So the first thing that we're going to do is find the expression for Kb, where we take our products over our reactants, leave out the liquid. The next thing that we're looking at is what is the conjugate acid of B? Well, conjugate acid is something that differs by one proton or one hydrogen ion. So that's going to be our Hb+. And then finally, we're going to find the expression for Ka. So if we take our Ka, we're taking that conjugate acid of B, so we have Hb+, we add that to water, we get the conjugate base, B, and H3O+. Now, finding the expression for Ka, again, we're going to take our products over our reactants. So why are we doing this? Well, now we're going to put everything together. When we multiply Ka times Kb, and then do a little bit of canceling out, what we find is that Kw is actually equal to the concentration of OH- times the concentration of H3O+. And we've seen this before when we were calculating Kw. So we've got a couple of new pieces of information that we can use. One is the one that we've already looked at. Our concentration of hydronium times hydroxide is equal to Kw, 1 times 10 to the negative 14 at 25 degrees Celsius. But now, thanks to our derivation here, we can also tell that Ka times Kb is also equal to Kw, or 1 times 10 to the negative 14. So this allows us to take any of the values from that relative strengths of Bronsted-Lowry acids and bases table and calculate a Kb by using the Ka of its conjugate acid. So we'll do a couple of questions that involve calculations like that as well. So in this example, it says calculate the pH of a solution containing 0.20 molar Cn-. So this is the weak acid of hydrocyanic acid, okay? So it's a conjugate base. So we're going to take Cn-, add it to water, and we get hydroxide and HCN, that conjugate weak acid. Just like in the previous lesson, we're going to set up an ice table with everything we know in it. So we've got the initial concentration of the Cn-, and we're starting with 0. That's our assumption that we're making for our initial concentration of hydroxide and the HCN. Next thing that we're going to do is we're going to put in x's. We're going to substitute in x's for everything that we know. And you'll notice that I'm making that same assumption that we did the last time with the acids. The 0.20 minus x, we're going to assume that equals 0.20. We're going to assume that that x is so small it's not going to affect that initial concentration. And we're stating that assumption. The next thing that we're going to do is we're going to bring in our relationship between Ka and Kb. So we know that Kw is equal to Ka times Kb. If we rearrange that equation, that gives us Kb is equal to Kw divided by Ka. Now with this one, you might want to pause the video and get out your acid table here so that you can find the conjugate acid of Cn minus. So what we're looking for is the Ka value of HCN. So if we look at the Ka value of HCN, that's the conjugate acid of the Cn minus, we find that that's 4.9 times 10 to the negative 10. So we're going to substitute that into our equation so that we can actually calculate Kb. And when we do so, we get a Kb value of 2.04 times 10 to the negative fifth. Now we can take that Kb value and use it for our equilibrium expression. So we're going to take our products divided by the reactants. We're leaving out the water. We substitute that Kb value in, substitute in our x's, and then we can solve for x, which is the concentration of hydroxide. When I do so, when I rearrange that formula, multiply both sides by the 0.20 and then divide by x, I get, and then square root, I get 2.02 times 10 to the negative 3 moles per liter. Last step with this is that we're going to take the negative log of that concentration of hydroxide so that we can get that to a POH. And then the last step is, because it's asked for a pH value, because almost nobody talks in POH values, we're going to take 14 minus 2.69, and we get a final value of 11.31. There we go, solving the question. So it's very, very similar to the process that we learned for weak acids. The only difference is we've got a couple of extra steps along the way to calculate the Kb, and then at the end to turn it back into a pH value. So on this page, I have grabbed some examples from your workbook here. And what I'd like you to do is to pause the video and try and answer these 3 questions. And after you've done that, I'll show you just the answers to those. If you're still having problems, please set up a Zoom meeting with me and I can go through how to get those answers if you're not having any success on your own. So there's the answer to the 3 problems. And again, if you're having difficulty with these problems, let me know and I can walk you through it. It's not an easy topic. It's definitely the hardest topic in our acid and base unit, but I think everybody in our class definitely has the ability to get through this if you break it down step by step. Okay, our next type of question, just like we did with the weak acids, is this time we're going to calculate an initial concentration of a weak base if we're given a Ka value and a pH or POH. So we've got a sample question here. What concentration of ammonia would be required to produce a solution with pH equals 10.50? With this one, because I'm given a pH value already, I'm going to convert that to baseland. So I'm going to try and keep everything in baseland until I'm ready to go right back at the end or figure out what I'm talking about. So with this one, I'm going to take that pH value, I'm going to turn that into a POH, and then I'm going to take the POH value and convert that to a concentration of hydroxide. So I do that by taking the antilog. So I take base 10 raised to the negative 3.50, and I get 3.16 times 10 to the negative 4 moles per liter of hydroxide. So there's kind of my first step. The next step is I'm going to write out my equation. So you can see that I've got an equilibrium expression here. I'm showing the conjugate acid and the hydroxide that's produced. I write out my ice table and I'm going to fill in what I know. I know the initial concentration of ammonia. Ammonia is what I'm trying to solve for, so I put C0 in there, so initial concentration. I know I'm starting with 0 moles per liter of the NH4 plus and 0 moles per liter of the OH minus. And I also know, because of the calculations that I did above, that my final concentration of this should be over in the OH minus category there, is 3.16 times 10 to the negative 4. Although, truthfully, the NH4 plus is going to be the same as well. We just didn't know that from the start. Okay. Next thing that I'm going to do is I'm going to fill in the rest of the chart, because it's kind of like figure out what you know and then go from there. I know I've got a 1-to-1-to-1 ratio, so the right-hand side are going to go up, the left-hand side is going to go down. So my equilibrium values, I've got C naught minus 3.16 times 10 to the negative 4. Don't need to make any assumptions because there's no quadratic. And on the right-hand side, both of those values are 3.16 times 10 to the negative 4. Although I did make that mistake, I should have written it under the OH minus instead of the NH4 plus when we had that initial value. Okay, next step is I'm going to write my Kb expression. So I want to solve the Kb using the Ka found on the chart. So I know my Kb is going to be Kw divided by Ka. I substitute those values in, so you can see that the Ka value for the conjugate acid, the NH4 plus, was 5.6 times 10 to the negative 10. When I substitute that into my equation, I get a Kb value of 1.79 times 10 to the negative 5. Next thing that I'm going to do is I'm going to use that equilibrium expression and this time put it in for my Kb. So I do products over reactants, substitute my Kb value in there, substitute all of those equilibrium values in there, and then I'm going to solve for C naught. When I rearrange that expression, I get a C naught of 5.9 times 10 to the negative 3 moles per liter. And again, if you're having difficulty doing this, please let me know if you need some help with the math and the rearranging as well. So again, there's some practice problems for you to try on your own. See if you're understanding this section. So these ones all are calculating that initial concentration of the weak base as well. And with most of these, you can kind of be careful. In the first question, the Kb is actually given for you. In the next two questions, you're going to be expected to calculate a Kb using the chart. And just be careful about what they're looking for, because you also may be required to use stoichiometry to find mass. So there's the solutions for those three problems. Again, if you're having difficulties with it, just set up an appointment with me or send me an email and I can work you through the full solution. Okay, last type of question for today is calculating the Kb if we're given a pH or pOH of the solution and an initial concentration of a weak base. So this time we don't know a Ka value. We need to figure out what the Kb value is, and we don't necessarily have to be at 25 degrees Celsius. So with this question, it says a solution is prepared by dissolving 9.90 grams of the weak base hydroxylamine and H2OH in enough water to produce 500 milliliters of solution. So we're going to have to go through a little bit of stoichiometry right at the beginning of this problem to get our concentrations. And we're also told that the pH of the solution is 9.9. And again, we are supposed to be working in baseland, so we're going to need to calculate concentration of hydroxide from that value. So we're going to have to go through a couple of calculations before we get to our ice table. So the first step that I'm going to do is I'm going to go through the stoichiometry to figure out what the concentration of that weak base is. So I take my 9.9 grams and I'm going to divide by the molar mass to get rid of the grams. And then the last thing I'm going to do is divide by the number of liters as well, so that I get a moles per liter calculation, because molarity is the only thing that can go into that table. So there's the first set of calculations. Second set of calculations is to get the concentration of hydroxide. So right now, I've given a pH of a solution. I'm in acid land. So the first thing that I'm going to do is I'm going to transfer over, I'm going to cross that bridge over into baseland by taking 14 minus 9.904. So I get a pOH of 4.096. Next thing that I'm going to do is I'm going to calculate a concentration of hydroxide. So I'm going to have to anti-log this. I take 10 to the negative 4.096, and I'm going to get my concentration of hydroxide, and that is what I'm going to put into my ice table. So that's the next step. So I write down my equilibrium expression for this weak base with the water. You'll notice that it is a weak base, so it's going to be accepting a hydrogen, and we get a hydroxide as the base that's created from this. Fill out my table. The first thing that I can put in is that initial concentration. That's what I calculated from that first calculation with the stoichiometry, so that's 0.60. I start with 0 of the conjugate acid and the OH minus. And the other thing that I can fill in is my concentration of hydroxide from the calculation. So it was 8.02 times 10 to the negative 5. Next step is to complete the table. So the right-hand side is gaining, the left-hand side is being reduced, or is losing molarity, and at equilibrium you can see the values there. The next thing I'm going to do is I'm going to plug those into my Kb expression. So my Kb expression is going to have the NH3OH plus multiplied by the concentration of hydroxide, and then we're going to divide by the products. So I plug in all of my equations in there from the equilibrium values, and I can calculate Kb. I get 1.07 times 10 to the negative 8. No units because we're talking about an equilibrium constant. The last set of practice problems is for you to try calculating Kb given initial conditions as well. So try these ones out, pause the video, and then come back and you can check your answers as well. So there's the answers to the equations. We were asked to calculate Kb and percent ionization in the first question. One of the questions in this is assuming that you've read the rest of the textbook. It's kind of asking you about the Kb value and what can we surmise from that Kb value. That it's higher than the previous question means that that temperature is going to be greater than 25 degrees Celsius because we'll have more ionization at a higher temperature, and that is what makes the Kb higher. Question 2, we've got a Kb and we also have a pKb. Anytime you're asked for a pKa or a pKb or any of that, you just take the negative log of your Kb number, and that's how you get that value. And in the third question here, we have the Kb for that weak base, and you just go through your same tables to get that as well. So again, look over your notes, go through the videos as well, see if you can get these questions. And if you have any questions, please, please, please don't hesitate to text or email or set up a Zoom time with me so that you can learn this stuff. Thanks for watching. See you next time.